Today we're going to be talking about the building as a product, and that involves platforms, processes, and projects. So a lot of the letter P, and we'll get into what that all means and the differences between these two things. And I think it's fundamental to show how industrialized construction differs from traditional construction. As a short reminder, last class we introduced a framework for industrialized construction. You see here we have this wheel with these 8 areas and the 9th area that wraps around it. And this in the second section in our guest lecture, Dr. Jurker Lessing will present Bo Kluk as a case study, and he might also say something about this wheel. I'm not sure, but he is the one that developed it as part of his PhD research. And today's class, we are going to be talking specifically about 2 areas. So I would kind of say that this conversation is really around these 2 areas, which is the planning and the control of the processes and the development of the technical systems, and also on the kind of connection points between these 2 areas. So if you think about the wheel, that's really what we're talking about today. So today I wanted to start with a discussion on the Jamboard, which is the question I'd like you to talk about is the phrase, the building as a product. So what does the building as a product mean to you? And I also just want to take a moment to acknowledge just how far we've been in 1 year. So I actually wrote this slide exactly as it was 1 year ago, right in our very first breakout rooms with Zoom and Jamboard and a lot of these new technologies, which you've probably now become used to, but I had to give very specific instructions like how it was going to work and how the whole closing the breakout rooms would do. And I just found that quite interesting 1 year later that now it's a normal part of our lives. So let's just take a moment to acknowledge everything we've been through in 1 year, and what an interesting time that we now are in. And so now I can just say, okay, go to Jamboard. Here's building as a product, and get started. So it's a far different world. So what I'm going to do now is I'm going to open the breakout rooms for 5 minutes. I'm going to let you choose. So if you want to pick whatever breakout room you'd like, that's fine. You could go in your teams, but you can also just join with some friends. It's fine. And just keep the limits to no more than let's say 4 or 5 people per breakout room. So the breakout rooms are open. I'll post the Jamboard in the chat, or it already has been by Alex. Thank you very much. And go ahead and discuss, and then come up with a couple Post-it notes. What does the building as a product mean to you? All right, breakout rooms are open. And sometimes some people have trouble jumping into the breakout room by yourself. So if that's your case, then let me know, and I can move you manually. But otherwise, you should see an option to join a breakout room yourself and to select the breakout room. Yep, and this, Alex makes a good point in the chat that this is on page 4 of the Jamboard. So go to page 4 for the place to put the information. All right, welcome back, everyone, as you're coming back in from the different breakout rooms. I have here shared the Jamboard, and I just want to point out a couple of key points here that I really like, and I think everything is kind of getting around or touching on the main comments here. I like here that we talk about that it's accessible like a consumer product. So what does it mean for a house or another building to be accessible and like a consumer product? This here, talking about building not as a prototype, right? We've talked about that a bit. So thinking about the building not just as a prototype, but as a continuous process. We'll talk a lot about that today. We hit on some other things like cost control. This is also important in product design, customization, yeah, lots of different ideas here. So I don't have time to talk about all of them, but this is a good warm-up. And now let's talk about the differences between these P words that I've mentioned so far. So we're going to be talking today about projects, processes, and platforms. And I think it's key that we start first with a set of definitions so that we all know what we're talking about when I'm mentioning these things, right? So let me just get my Zoom stuff out of the way here. Okay, so we've got a project. First, we're going to talk about project, then process, then platform. Okay, and platform looks the most fun. It's got Legos. Okay, so what is a project? A project is a series of activities. It's defined with a starting point and an end point. And there's a certain amount of resources that are allocated to it. We are very familiar with projects in construction. Almost all of construction is made from projects. But a project is a very specific type of organizing, and it's found in the built environment quite a lot, but in other places, maybe not so much. And a project exists only once and has its own unique prerequisites. It's very specific, and this is where we talk about this, you know, not making a prototype every time. There are very specific contexts for a project. In buildings, it's the site, right? So there's a very specific construction site, and it has its own unique characteristics, could have its own building codes, could have all of its own unique parts of it. This is not going to change. We still are going to need projects. So let's be clear about that. They're still a part of the discussion. And here is kind of maybe how a project might look like in an industrialized construction context, right? So you design and plan the building. Then you have some manufacturing activities that might happen offsite. But at the same time, you might prepare the foundations, or you say groundworks, or whatever it is, the foundation work. And then when that's all ready, you come together for assembly of the product, of the different parts and components. And then you might have also some final site work. So put some nice landscaping up, or some painting, or something like this. So this is the idea of what a industrialized construction project might look like. Next, let's talk about what is a process. And again, I think it's an intuitive idea. We understand this idea of process, but it's good to define it. So a process is a continuous flow of activities that uses information and resources to fulfill its role, to create value for the customers. Now, the important difference here is that a process is continuous. It's meant, when you design a process, it's meant to be something that's reused over and over and over again, right? So for example, we have a process for how we enter the class. I give you a Zoom link and you click on the Zoom link, right? That's a process. And a process does not have a clear start and end point in time. So the whole goal of a process is that it just exists and can be used as it's needed to be used. And so we're talking about information and resources, all right? So we have project, and then we have, the project has a start and an end date and very specific prerequisites. A process is continuous. It uses information and resources, and it has something to do with creating value, right? There's a goal of a process, but it's meant to be continuous and does not have a start and end date. And third, we have to introduce the idea of a platform. So here is the technical definition of a platform. A platform is a set of common components, modules, or parts that form a common structure from which a stream of derivative products can be efficiently developed and produced. That's the very highly technical definition. I like the more playful definition, which is you can think about Legos and the design of Legos as an example of a product platform. And, you know, I like to say that the Legos follow this like single dot. So this is what I said when I was playing with Legos, a single dot rule, right? So there's kind of a standard spacing between these little bumps or dots on the Legos if you've played with them. And so we understand that this is the rules of the Lego platform. And then you can kind of create new pieces within that technical framework that fit and follow the rules of the defined platform. So you're not limited if you want to build an arch piece here, you see, you're not limited to not developing new pieces. It's just that the arch needs to follow the same geometry rules and product rules as the other pieces. So you can innovate, but you have to follow the rules of the platform. And then from this platform, you can develop projects, right? So you can use them in many different combinations of ways and develop these different projects here. And so platforms allow multiple projects or products, depending on the field, to be built within the same technical framework, right? And let me give you another example. This is the Volkswagen MQB platform, as they call it, the Modular Transverse Toolkit. And the development cost for Volkswagen to develop this platform was 60 billion, I think US dollars, I think it was euro, I can't remember if it's US dollars or euros. It was 60 billion. That's how much time they put into developing the platform, not into making specific cars, but into the development of the platform itself, right? And here's how they define the platform, right? So they specifically make a uniform spacing between the center line of the front axle of the car and this piece of the chassis. And this is uniform. This cannot change. But what can change is the spacing to the front of the car and the other spacing parts, right? So their definition of the MQB platform was to make things very specific in one part and then have other measurements where you could have some variability, right? So they put 60 billion US, or equivalent of $60 billion into this. And from this platform, then they're able to create a stream of what we call derivative products, right? So you take this platform and you set this as constant. So you've put a lot of investment into making sure this works really well. And then you can have different concepts that come from this, right? So here are all the different types of vehicles that are built upon the MQB platform here. So if you've ever been in any of these vehicles, either from Volkswagen or Audi or Skoda, these are all the different types of derivative products that can come from the same platform. And you know you have a consistent measurements within the rules of the platform. Okay, so that works in the car industry. How does it look like in the industrialized construction world? Here's what I like to say is our 4 stages of an industrialized construction project, which is similar to normal construction projects as well. So you have your design and your customer acquisition. We have some kind of engineering. In industrialized construction, we'll talk about configuration engineering. Then you have manufacturing and production. Maybe it's going to be offsite. And finally, if it is offsite, you have assembly and logistics. And one thing that we're used to doing in construction is we take that information and we pass it along downstream, right? So this is the typical, I would say, BIM-based construction management process. A designer will start with a blank sheet of paper, but then they'll start adding things to a digital model, right? So they start adding the walls and the windows and starting to provide more information. And as the project moves along in time, you start adding more and more information until you get to the very end, and that's the final completed project. Now, what a platform allows you to do is, in addition to just transferring the information downstream, the difference is that you also have the opportunity to transfer rules and restraints upstream. What I mean by that is that if there are certain rules and requirements about the size of the modules that can be shipped, such as the type of transportation you're going to use, certain types of trucking or things like this, you can then start to put those rules into your product platform. If there are certain machines that your company has invested in that have limitations to what they can do, you start putting those earlier and earlier into the upstream design and customer acquisition. In addition, if you configure the building with certain rules, then you can also transfer these upstream. So this is the idea that the platform approach not only lets you pass information downstream to the later parts of the supply chain and stakeholders, but it also enables you to pass information upstream so that you can start to make sure you don't design things outside the rules of the product platform as you see it. Now, there are different types of platforms, and you've probably heard me use the phrase product platform. And I want to be clear that there's kind of different ways of understanding platforms. So this is a definition that helps kind of understand this a bit better. Overall, the product platform is kind of synonymous for what I would call the technical platform, right? So the technical platform is the set of subsystems and interfaces of the product family. And so if you think about it, if you have a whole building and it's made up of some panelized walls and a certain roof system and trusses, that all together makes the product platform. And there are these subsystems that fit within this. So there's the modular and systematized architecture. There's the interfaces connecting the subsystems and the standards and design rules to which the modules conform. That all goes into the technical product platform. Now, there's also the process platform, and the process platform is the setup of the production system, which is just as important. So it's how do you set up the production system so you can achieve the variety of products that you want. And if we're going to talk about mass customization or configuration of buildings, then we start talking about the idea that there's a need for a process platform so you can get the right level of variety that you want in your products. And I'm going to give a bit more of an example in a moment. And finally, there's this idea of a digital platform, or sometimes we call it a configurator. And we'll talk in 3 weeks about what is a digital platform or a customer acquisition or design tool. How does that work? How do we configure using such a digital platform in a very lightweight and easy way? But that's not for today's lecture. So that's coming up in the future, this digital platform idea. So let me start first with the process for technical platform development. Okay, so here is the process that you need to follow in order to develop a technical product platform. And it's one that you'll also have to think about each of these 5 areas in your course project as well. So you have to develop technical solutions for the building parts, right? So each part and component, you have to think about what is our technical solution, of course. You have to develop a structure for the overall platform. So are there certain rules or structure to the way that the product works? Like, will you design on a grid so that every 1 meter you can make a kind of a change, or will it be more flexible, less flexible? These are some of the structure questions. Will you develop common interfaces to make the components interchangeable? So this is key in Legos. If you think about the example of Legos, the common interface is these dots. So this spacing is the way that you make things interchangeable. Will you develop the suitable solutions for prefabrication industrialization? So does your technical platform match your fabrication capabilities? And are you creating the supporting technologies such as the advanced IT tools or configurators, which we'll talk about in a few weeks. So this is how you develop your technical platform. You also have to develop a process platform. So this is something you should think about. You won't have to put as much work into it for the course project, but you do need to have some time thinking about your process platform. And you should be able to standardize process and methods and divide into modules. So this doesn't mean modules as in volumetric box modules. This means modular structure to processes. So one stage ends and a new stage begins. And this involves developing of planning methods and structuring the production methods and sub-processes. So you can start to think about how does the entire step-by-step process of fabricating your building exist? Or what is the step-by-step process of designing your building or your facility? And it also includes structuring the methods for information sharing and support with adequate tools. So who gets access to what information? Who are the stakeholders involved? Methods for continuous improvement, of course, and supporting IT tools. Now, we also need to think about what's the relationship between processes, products, or product platforms and projects. And that's what we'll talk about here. So if you think about it, it's going to be a continuous process. You don't want to develop your technical platform once and then never work on it again. The development of a technical platform is continuously improving, and Volkswagen is developing their next technical platform now as we speak, right? It's because they're not going to just be satisfied with one and say that will exist forever. So you try to improve from stage to stage, and then you want to also have an interface between the product platform and the process platform. For example, you might find that you expected your product to be built in a certain way with a certain type of manufacturing, let's say CNC machining, but you found out that actually that's not the cheapest way to build. There was a better way to build on the production line. So therefore, you've switched now your technology, and it changes a little bit on this specific type of product that you want. So you start to inform each other on how the product design interplays with the process of fabrication. And so that's this idea of an integration between the two. Now, importantly to mention as well, customers don't buy platforms. You cannot sell your platform to an end customer. We are in the business of projects. So unique buildings are built using projects, but these projects now can be based on the solutions from the platform. So again, it's not about doing a prototype, it's about developing a clear platform approach, but then basing your projects on solutions from that platform. And then that allows you to decide if you want to enter in certain levels of customization. You can design that into your product platform. So you might like to have a lot of customization, and you might only like to have a little bit. That's up for you to design with the product platform. And I like to think about it like this. We heard kit of parts was one of the post-it notes we saw at the beginning of class. If you think about it this way, you have a product platform. So these are the rules, the technical specifications that you have to follow. Then when you're ready to develop a project, you create a specific kit. So a project kit that can be used, or we hear the term kit of parts. If you buy a set of Legos, this sheet used to be included on every set. I don't know if it still is. I think so, because my son, I think, had it on his recent set. It tells you exactly every piece that's going to be put into that specific project that you're going to make. And this would be the equivalent to a bill of materials. It's a list of all of the different specific parts that are coming with that set. And then you can develop your projects using these kits, right? So the idea would be you have a platform, you design a project, and it uses your kit. It doesn't have to use every piece, right? But it does follow the rules of the product platform. Then you decide to ship. So you have your bill of materials, and you ship those parts to the construction site to be assembled. So that's the intersection between the product platform, the project kit, and the projects. And here's how it all kind of fits together. So here we have our technical platform, our process platform, and then here you see our kind of the idea of a specific building project. So the idea is that you want to have your knowledge flow go from the technical platform to the projects. We don't want to start the project from scratch. We want to have put some investment into our product platform and then develop a project from that. But of course, we're going to learn a lot from implementing our first project. So then we want to have the opportunity that the knowledge flow goes back from the projects into the product platform. So the idea is that as you complete your first project, you start to have information going, back and informing the next version of the platform, so that the platform is improved and the future projects are then improved. And the nice thing is that then the platform becomes the storage of all of the knowledge, right? So as you improve the platform, you store all the best practices in the platform itself and not in the minds of the workers, because as we store it today, it's usually in the minds of people. And if that person leaves, you lose all that knowledge. And what it looks like overall is something like this. So here are the different projects, X1, X2, X3, and Y1. You'll see why it changes in a moment. But let's say you have a version 1.0, or as we will call it in this class, your minimum viable product. So your very first product platform. And you initiate project X1 using that process. All right, so we've initiated now the first project from the platform. And as time goes on, you still are building off of that first platform, and you have project X2 and X3. They've all been initiated from the first version of the platform, version 1. But then project X1 is going to finish, right? So you're going to say, okay, we finished project X1 and we learned a lot. We actually figured out a lot of things that were not good about our platform design. And so we are going to now implement those improvements into version 2.0, right? So here you see now we've released platform 2.0. It's too late for project X2 and X3. We don't change them. We don't try to say, okay, now let's update all of our projects at once. They are already built with platform 1, let them be, and we're going to just focus now on version 2 moving forward, right? So now project Y1 is built with version 2.0 of the product platform. And meanwhile, you have these knowledges from X2, X3, and Y1 all flowing back into the platform. And then we can initiate version 3.0 of the product platform, right? So now version 3 will be even more improved. And what I'm speaking about is not new to manufactured goods or software. This is actually quite a normal process of updating our products. But for construction, we very rarely capture this information, right? So to summarize, the version 1 is that minimum viable product. We'll speak more about what is a minimum viable product later in the class, but it's basically your core, your first offering that just meets the minimum needs of your users. And each later version is going to represent an improved product. So you start to put in more functionalities as you go further in design. But you don't try to design the entire platform at once, right? That will be too difficult to get everything right with the very first platform. All right, so we have about 10 minutes left, and I have a very short case study of what this looks like with a company called VEIDEKKE Max. It's another Swedish company that I visited in 2016. So if you haven't noticed, this has a very Scandinavian focus in this lecture and some of my lectures. This was a visit to them when I was looking. They were talking about this was a specific project, and here you can see a little bit of their weeks and their process and how they were tracking their processes. And VEIDEKKE developed something that they called their industrialized building system. And here you can see, again, they really focused on their technical platform, and then they had a process platform. So these were some details. We won't get into too many details. I just want to show that they had a modularized approach where they had standardized components and interfaces so they could configure their unique buildings. So, here you can see this is kind of like I'll speak more about what this is in a moment, but they had some standardized staircases and concrete, again, showing industrialized construction can be done with prefabricated concrete as well. And their idea was to standardize the building parts that don't add value to the end user or the client. So they were trying to only customize the things that add value and standardize everything else. So they wanted to standardize the apartment height, the walls, the columns, the staircases, etc., and then customize the design of some of the more customer-focused things like the rooms and things like that for the specific location. So that was what they approached, and they developed a new product that they called the heart of the building system. So it's a kind of, I would call it a bathroom pod deluxe with a kitchen on the backside. So they have a lot of the services here, and then they have the kitchen on the other side of the wall, right? So you can kind of see here's a lot of the services, and then here's the kitchen. And they also had something that they called the spider, I think, or the octopus on top, which would run from the top, I'll show in a moment, to all the different rooms in the house, right? So here's kind of what it looked like. So here's the modules that they built in their own factory. So 90% of all the installation work was finished offsite. Here's the prefabricated modules. And traditionally, they would have many trades that would build these systems, right? So they would have electrical, plumbing, mechanical, all these different trades would have to come through in very tight spaces. And they found that these tasks were on their critical path. So these were the ones that were causing the most time in the building construction. So they wanted to focus on this. Sorry, I can't quite see. The new Max system, they tried to create this heart pod that had few or no handovers between trades to speed up the whole process and shorten the critical path activities. So as part of the product, they had to find a quicker way to make connections in their electrical systems, because they were finding that the electrical systems were taking a long time to then connect from their heart to the different rooms, because that's where all the services were. So they created this thing called the octopus, right? So here's, again, my Swedish not so good, but basically here is this main connection point, and it would run out like arms of an octopus and run through through all the different, I believe it was the floor system, but it might have been the roofing system actually, to connect with the different electrical systems. Here you can see what it would look like is you have your pod, and this box would sit on top, and you have all of these quick connect electrical fixtures that would run to the different outlets. You can see here are the different outlets on the plan drawing. So again, it's this idea that you productize and create a product that fits your specific overall system design in a better way. So then they also designed their process platform, right? So it was not just about designing a new product, but also thinking about the process platform. And they went for a digital workflow. So they spent 8 to 16 hours just kind of outlining the building, 4 to 8 hours importing a model from the architect so that they could then kind of customize it with their building system, and then finally come up with the bill of materials, the cost, the schedule, and LOB stands for line of balance, which is a scheduling technique. We won't have, I don't have time to talk about that right now. And overall, they found that the tender process to the client took about 50% less time and involved less people. So, and it gave them a much more accurate tender approach. They also developed their on-site instructions. We've talked about this before, but this is part of the process platform. So how do people install their systems in a way that makes sense? Because not everyone can read our detailed plans we're used to making in construction. So this was examples of how to install some of the stair systems. So they're saying, like, here's a risk moment, be careful, don't think very carefully about this stage, because this is going to be a dangerous step. And finally, they also, in their process platform, they developed specified tool trolleys for the specific activity. So the idea would be you want a tool trolley that has all the materials, tools, and equipment you need and nothing that you don't need, right? So again, it's about less waste in the idea that you don't need extra things. You don't need everything that creates more confusion for the workers. But if you have a specified product, you can then provide specified tools for them to install on site. So here is an example of also thinking about the worker as a part of the process platform. Okay, so I can summarize here about platforms, processes, and projects, and then I think we have 5 minutes for questions. So you want to separate the development processes from the building projects. Again, the development of the platform, as we saw with Volkswagen, is a different and separate thing than the actual project itself, the actual building of the car, or the building construction of the building. The platform is a different thing. You establish the information flow in both directions, from the platforms to the projects, and then back from the projects to the platform. And you need to find a fit within your company's organization for how this will work. And this introduces new roles in construction, also partially why you have a different role for your projects. You need to have a lead product designer, or a product platform manager, or a process improvement manager, right? These are not traditional roles found in architecture, engineering, and construction. It also introduces new tasks, such as configuration and design of configuration platforms, product system development, and someone that focuses on the continuous improvements. If I would summarize the difference between project design that we traditionally use versus a platform development, project design looks at unique team solutions and building. Starts from a very low levels of common knowledge, because you start with every building as a prototype. Your input from production is quite rare. It's hard to get that information from production if you don't know what your specific product is going to be. You have many options, so it's hard to get that input. There's limited levels of detail. The project is always a prototype, and it's very hard to continuously improve because you've not invested in common processes. So you have no reason to keep those processes for the next project. By contrast, platform development continuity is really the foundation. It's about continuous approach. The solutions are based on repetitive use because you improve them over time. A platform development team gets formed, and it has multiple competencies, from maybe structural engineering, house technique, architecture. They all contribute to the platform development. There's high level of detail, but you must spread the cost of platform development across your many projects, right? So you have to think about the business model for a platform requires investment in the platform itself, but then you have to make that back in your projects. And your solutions then can be tested before implementation, because if you invest in a product platform, you should also test that these actually work for you, and before you deploy them on projects. If I would summarize, the key word here is continuity for the platforms. And it's all about continuity in technology and systems, continuity in process and methods, and continuity in the team and the relations with one another. All right, so thank you very much for your attention.